This is a tutorial for Climate Consultant 5.4. In order to get started with Climate Consultant, you have to first input your weather data for the location of your project. Weather data is in EPW format, Energy Plus Weather data file. You can access the 16 California climate zones as built-in databases within Climate Consultant. If you have a location outside of California, you'll have to download the EPW weather file from the Energy Plus website. Let's go ahead and load our weather file. I'm going to click Start a New Project, Imperial Units, Open Existing EPW Weather Data File. I'm going to use California Climate Zone 5, that's where San Luis Obispo is located. The beauty of Climate Consultant is that it takes a really sort of amorphous text file and puts it into very clear and easy to understand graphics, a task that if you had to do manually or through some sort of data organization software would be pretty tedious. We need to select the parameters by which the weather data will be evaluated. The default is California Energy Code, which, as long as your project's located in California, you should go ahead and use that. And for this homework assignment, we encourage you to use the default. Please feel free to play around with the other standards and see how it changes your design strategies. As a starting point, you should leave the default values that are input by the California Energy Code. You may want to adjust your comfort level temperatures, this is Fahrenheit temperature, based on your building use and activity level. For example, something that uses a high level of energy, you might be more comfortable at lower temperatures versus something that's a very passive activity, you might need to put these to higher temperatures. It could also be interesting to estimate what a difference it would make in your design if you were able to just change the comfort zone a bit. The first chart is just temperature. On almost every chart, you're given some indication of the thermal comfort zone, as indicated here by this horizontal gray bar. Notice that in Climate Zone 5, we are well below the comfort zone. The mean temperature is well below the comfort zone throughout the entire year. The monthly diurnal averages shows us both temperature swings and the amount of sunlight available on an average day in any month. So even though this is January, this is showing an average January day. The lower three measures are essentially ways of understanding the amount of sunlight available, whereas the temperature and wet bulb, dry bulb and wet bulb are shown above. Notice again the relationship between the comfort zone and the temperature. The radiation range graph again is letting us know how much sunlight is available on a surface. By default, this is set to 0 degrees, which means a horizontal surface. You can rotate the surface angle over here in these boxes on the left. If I change to 90 degrees, that's a vertical surface, and you can see that we have considerably less available radiation, especially in the summer months. This graph would be really helpful if you were working on photovoltaic design. Sky cover range is a measure of cloudiness, whereas 0 is clear skies and 100% is total cloud cover. You can see that in San Luis Obispo we hover right around the 50% mark, meaning that approximately 50% of the sky is cloudy. The sun shading chart is one of the more valuable charts in Climate Consultant. This shows us each of these dots shows hourly data for temperature at different times of the day and different times of the year. Currently we're looking at December to June. And you can see that red dots show temperatures that are above the comfort zone, blue dots are temperatures below the comfort zone, and yellow are those within the comfort zone. One of the great features of this particular chart is that you can use it to help calculate shading. Let's go ahead and look at June to December so that we have more hot temperatures on the screen. So this graph is showing that we do actually need some shading in the middle of the day in the summer months. So if we turn on the display shading calculator, you may get this little help screen, which is great. Go ahead and read it. For now, I'll close it and show you what it's talking about. You get an overlay over your drawing that would help you to determine the angle at which your shading device devices should be sized, and exactly what time of day and what time of year those shading devices would be effective. The way that you read this chart is actually from top to bottom. So if you grab this circle and pull it down, you can see what becomes shaded in gray. That's the area that would effectively be shaded by a shading device that is 80 degrees from the bottom of the window. If you took a line horizontally from the bottom of a window and then measured 80 degrees up from horizontal, any shading device that fell along that 80-degree line would effectively shade as shown here in the gray area. So as I drag this down further, I can see that I would actually need to project that line at a 50-degree angle in order to effectively block out this summer sun. This is measured from true south. If your building is not facing true south, or if you want to evaluate one of your other elevations, you can actually shift this mask to either side. And if you want to shade your windows with a vertical fin, you can actually pull in from the right side a vertical fin and get an understanding of how that fin would help to shade. In addition to architectural shading, there may also be shading on your site due to other things that are surrounding your building, such as neighboring buildings or trees. You can go ahead and input those obstructions based on the orientation. So if due south, you had a grove of medium trees 15 feet away from your building, it would like to know how the bottom edge of our windows. Go ahead and say OK, and those trees will now be masked over your sun shading chart. Let's say you had a neighboring structure that was 40 feet tall and sharing a party wall. Climate Consultant won't let you put a distance of 0, so you can use a quarter of a foot or 1 foot as an approximation for that party wall, and go ahead and say OK. Now you can see the areas where you don't need to provide architectural shading because your neighboring buildings will shade that portion of your building. The psychrometric chart is a really powerful graphic tool that'll help you identify design strategies to achieve thermal comfort. When you first click on the psychrometric graph, you'll get again some suggestions that Climate Consultant gives. Please read these. One of the things that it says it encourages is for you to try to use the least number of design strategies to achieve a high level of comfort. There is a psychrometric tutorial if this is all looking a little overwhelming to you. The link to that tutorial can be found on the introductory page when you first open Climate Consultant. I'd highly recommend that you take a look at that tutorial. In the psychrometric chart, you can simply click on a design suggestion in order to turn it off. You'll notice the ones that I've been clicking on have not had any impact on my comfort because they've been basically unnecessary design solutions for this climate. If I turned off one of the significant ones, now all of a sudden we see that 51% of the time the building occupants would be uncomfortable. So you'll have to decide what is an acceptable percentage. If you're uncertain as to exactly what's meant by the design strategies shown on the psychrometric chart, the following slide actually gives diagrams. If you click on any of these, you get a diagram that explains both graphically and verbally the intention of that design constraint. Wind wheel tool will allow you to discover if there are any prevailing wind directions and to also see if there are seasonal correlations between wind and temperature. One of the fun things about this graph is that you can animate it. So you can see either monthly, daily, or hourly how the wind behaves in a typical meteorological year.